Alright, so this is the two sums on Leetcode. Given an array of integers, nums, and an integer target, return indices of two numbers such that they add up target. So the important thing is return the indices. You may assume that each input will have exactly one solution. And then, so that's good because we know that there's never going to not be a solution. And you may not use the same element twice. So if it's 6, you can't do 2 3s like in this example. You can return the answers in any order. So here's the first example. It's just showing that 2 and 7 add up to 9. The second one, what it's showing is that you can't use 3 twice in order to get to 2. And then the second one is showing that sometimes the element will be in twice. So you can see 3 is in this array twice, so it's okay to use it to get the 6. The constraints, you're always going to have at least 2 elements. Another thing, the numbers could be negative, so that's important. And then the target could also be negative. So even though none of these show negative numbers, it is possible. So the easiest way to do this is just to check all of the elements, which is going to give you an n squared complexity. So that would look something like this. 0. I, j is less than nums dot size, j plus plus. And then we can we don't want to check the last element, so we'll just remove one there. And then this little thing here, so rather than starting at 0, you start at I. So it just saves some computation time, and it prevents you from getting I is equal to, it should be I plus 1, shouldn't it? Yeah, so it should be I plus 1 because that'll prevent you from ever getting the same indice for both I and j. So then we'll say if the nums dot at I plus the nums dot at j is equal to target, return, so we want to return the indices, that's important, so we'll just return the 2 indices. And then here, we just return, this should never happen, but we still need a return statement. So we can run this then. And you see, yeah, so that works. So another way you can do this is by using iterators instead. So how you would do that, let's just duplicate this real quick. Comment it out. So you would be doing, how'd you do this? You would say so the challenging thing here, so normally you can do a loop like this or an I in nums, but the problem here is this doesn't give index, which is a problem for here. So we have to keep the index. So we have to do the sort of longer loop. So actually I'm just going to ax this all. So we'll say for auto I is equal to nums dot begin, I is less than nums dot end, and again remember we can do -1 because we don't need to check the last one. Increment I, or auto j is equal to I plus 1, j is less than nums dot end, j plus plus. So then here you have to remember we have a memory address, so you have to get the value at the memory address. Turn. So then we need to do, this is just a teeny bit more confusing if you use iterators for this. We need to do you need to get I minus nums dot begin and j minus nums dot begin. And the reason for this, let me make sure this is still good. Yeah. Alright, so the reason for this, so we need to do a typecast. So if we just do I, it'll give you the memory address, whereas you want the offset, not the memory address. That's why you do the memory address minus the offset, or you do the memory address minus the beginning memory address to get the offset, and you have to cast to an int. So we'll go ahead and submit this. And you can see this actually did a lot better. I don't necessarily trust the Leetcode runtimes, but that was a pretty big difference. So that's if you're doing for loops and you want your n squared time complexity. So you can actually use something called an unordered map to make this faster. Alright, so how this is going to work is we'll loop over the nums. We'll check if the complement is in the used hash map, and then if not, we'll add the used. So let's just say for is equal to 0, I is less than nums dot size. And I want to loop all the way to the end for this one. We don't want to cut off at 1. So we'll say is int complement, is that spelled right? Complement is equal to target minus nums dot add I. We'll say, so in order to check if a element is in a hash map, what we do is we say used.find complement does not equal used.end. So this is basically saying is if it doesn't exist, it'll be the last element, but if it does exist, it'll not be the last element. So that's how we check if it exists. So if it does, we're just going to return. So remember, we need to return the indices, so it'll be I, and then we want to do complement, or we want to do use.find complement, and then second, and I'll explain that in a minute. So otherwise, what we're going to do is we're going to say used of used of nums dot at I is equal to I. So it's important not to flip these. So you want the key to be the value and the value to be the index. And this is important because if you flip them, so if you have this is I and this is nums.add I, then this search won't work. So we're searching for the value, we're not searching for the key. So we want to search for the value, and if the value is found, we want the indice. So again, nums.add I. So then back to this up here, use.find complement. So second is going to give the value. So first gives the key. No, first we'll give the value, the original value, and the second will give the index of that value. So you see how that works, where it was flipped. If that's confusing, you can look up how hash maps work. So let's see. So what it's going to do, it creates this used list. It does a for loop by index. It checks what the complement is. It says if the complement has already been added to this used hash map, it'll return it. Otherwise, it'll add it. So I'm just going to run this and see if it works. Oh, that's a good question. I wonder if I'm just missing a semicolon. Oh, I put the semicolon in the wrong spot. Alright, there we go. So we'll submit this. Let's see what it does. It says it runs in 12 milliseconds. So now, so this is a for loop. So now let's do the same thing where we're going to convert this then to an iterator rather than a for loop. So how this would be is it would say for auto I. So you can't, again, we need the indices, so you can't just do this way. You have to say auto I is equal to nums dot begin. I is less than nums dot end. I plus plus. So we need to do the complement again, so it should be the same. I'll just copy and paste it. So we need to check what the complement is. Then should this be the same? So this is, we say if the complement is, if we find the complement, we want to return this. So this I here is going to change. So what we're going to have to do is we're going to have to, so this is why I prefer to loop by index personally for this one, because I think this is just confusing. So we need to cast to an int, and we need to say I minus nums dot begin here. Because remember we need the offset. And then we'll copy this else loop in. Used of nums.at, and then remember again int of I minus nums.begin, and then we got the return statement all the way down there. So again, how this is going to work, we're going to create a hash map. We will do the iterator, and then so this is wrong here. I don't know why I copy paste this. So yeah, you need the value at the iterator. So we're going to get the complement, and then we'll say use.find. Complement does not equal use.end. That should be the same. Then we're going to return it. Otherwise, oh, this is wrong again. It's not. It's there we go. It's a good thing I copy pasted it. I went line for line. So then we're going to say used the memory, or the value at the memory address of the iterator is then the offset. So let's see if this works. Probably made a mistake somewhere, but alright, cool, that works. So last one ran in 12 milliseconds. This one runs in, just as this one's a little faster. But yeah.